stability and trim. List. Theory, plus worded problems. Consider a ship, floating upright. Its center of gravity, and center of buoyancy, are on the same line. The resultant moment, about the center of gravity is equal to 0, and the resultant force acting on the ship, is also equal to 0. A weight, already on board, is shifted transversely, such that G, move to G1. This will produce a listing moment of W multiplied by G1. And the ship will list until G1 and the center of buoyancy are in the same vertical line. In this position, G1 will also lie vertically under M, so long as the angle of list is small. If the final position in the metacenter and the center of gravity are known, the final least can be found, using the trigonometry, the triangle GG1, and M, which is right angle at G. A ship, of 6,000 tons of displacement, has km of 7.3 meters, and kg, of 6.7 meters, is floating upright. A weight of 60 tons, is already on board, is shifted 12 meters transversely. Find the resultant list. Given, displacement, is equal to 6,000 tons, km, is equal to 7.3 meters, kg, is equal to 6.7 meters, weight, is equal to 60 tons, distance, is equal to 12 meters. Required, list. Solution, solve for GG1. Formula use. GG1, is equal to, weight, multiplied by distance, divided by, displacement. Distribute the value, GG1, is equal to, 60 tons, multiplied by, 12 meters, divided by 6,000 tons. Crash out the unit tons, and the remaining unit, is meter. Results. GG1, is equal to 0.12 meters. Solve for GM. Formula use. GM, is equal to, km, subtracted by kg. Distribute the value, GM, is equal to, 7.3 meters, subtracted by 6.7 meters. GM, is equal to, 0.6 meters. Using scientific calculator. Press second function. Press tangent. Press second function. Press degrees, minutes, seconds. List, is equal to, 11 degrees, 18 minutes, and 35.7569 seconds. A ship, of 8,000 displacement, has km of 8.7 meters, and kg of 7.6 meters. The following weights are then loaded and discharged. Load 250 tons of cargo, kg of 6.1 meters, and center of gravity 7.6 meters, to starboard of the center line. Load 300 tons of fuel oil, kg of 0.6 meter, and center of gravity 6.1 meter, to port of the center line. Discharge 50 tons of ballast, kg of 1.2 meter, and center of gravity 4.6 meters, to port of the center line. Find the final list. 4 moments about the keel. Make a detailed information of the loading and unloading condition for the final kg and GM computation. In this example, the ship has 8,000 tons displacement, loaded a cargo of 250 tons, and loaded a fuel oil of 300 tons. Sum up all the loaded cargo, having a total of 8,550 tons. Discharged 50 tons of ballast. Subtract it to the total weight loaded, which is equal to 8,550 tons. The result is 8,500 tons. 4-moment computation about the keel of each cargo. Displacement, which is equal to 8,000 tons, multiplied by its kg of 7.6 meters, the result is 60,800 metric tons. 250 tons of cargo, multiplied by its kg of 6.1 meters, the result is 1,525 metric tons. Fuel oil of 300 tons, multiplied by its kg of 0.6 meters, the result is 180 metric tons. Sum up all cargo loaded, the result is 62,505 metric tons. A ballast of 50 tons, multiplied by its kg of 1.2 meter. The result is equal to 60 metric tons. Subtract it to 62,505 metric tons. The final moment is equal to 62,445 metric tons. The formula for solving the final kg is final kg is equal to final moment divided by final displacement. Now distribute the value. Final kg is equal to 62,445 metric tons divided by 8,500 tons. Crash out the unit tons, and the remaining unit is meter. The result is the final kg, which is equal to 7.35 meters. For final GM, the formula is km subtracted by kg. Application of the formula km is equal to 8.7 meters subtracted by kg, which is equal to 7.35 meters. The result is the final GM is equal to 1.35 meters. 4 moments about the center line. A detailed information for the loading and unloading condition, for the computation of the final listing moment, and for the final list. A cargo of 250 metric tons, multiplied by its distance to starboard, which is equal to 7.6 meters, the result is 1,900 metric tons, to starboard. Fuel oil of 300 metric tons, multiplied by its distance to port, which is equal to 6.1 meters. The result is 1,830 metric tons, to port. Ballast of 50 metric tons, multiplied by its distance to starboard, which is equal to 4.6 meters. The result is 230 metric tons, to starboard. 2,130 metric tons, listing moments to starboard, subtracted by 1,830 metric tons, listing to port. The result is the final listing moment, which is equal to 300 metric tons, listing to starboard. Final listing moment is equal to W multiplied by Gg1. Transpose the equation to calculate Gg1. The formula now is Gg1 is equal to final listing moment divided by the final displacement. Distribute the value. Gg1 is equal to 300 metric tons divided by 8,500 tons. Crash out the unit tons, and the remaining unit is meter. The result, Gg1, is equal to 0.035 meter. The formula for solving the final list is tangent theta is equal to Gg1 divided by Gm. Distribute the value. Tangent theta is equal to 0.035 meter divided by 1.35 meter. The result is tangent theta is equal to 0.0259. Press second function. Press tangent. Press second function. Press degrees, minutes, seconds. An upright ship has a displacement of 8,000 tons and kg of 7.6 meters. A cargo of 250 tons, kg of 6.1 meters, with a distance from the center of gravity of 7.6 meters. Fuel oil of 300 tons, kg of 0.6 meters, with a distance from the center of gravity of 6.1 meters. Ballast of 50 tons, kg of 1.2 meters, with a distance from the center of gravity of 4.6 meters. Discharging the ballast of 50 tons. Thank you for watching. Please subscribe and click the notification bell, for you will be updated for our next upcoming video.